If you're a fan of stargazing, and you've had a bit of luck, you may have seen a row of dots moving swiftly across the night sky. Meet the Starlink satellites, one of the flagship projects of Elon Musk's famous company, SpaceX. As antennas and fiber optics don't provide adequate coverage in many parts of the world, Starlink plans to create a gigantic satellite network so that anyone, anywhere, can have broadband internet access. Although it's still in a testing phase, the company's already revealed it can offer download speeds of 100 megabytes per second. Not bad. And when I say gigantic network, I'm not kidding. In contrast to the dozens of satellites that form other constellations, like those of the GPS system, Starlink already has hundreds in orbit. But that's just the tip of the iceberg. The launch of 12,000 satellites has already been authorized, and SpaceX has already filed for permission to increase this number to a whopping 42,000. In other words, rather than a satellite constellation, we are talking about a megaconstellation. The thing is, the Starlink constellation isn't the only one on the table. Facebook, Amazon, OneWeb, Link, Telesat, Hongyun, and others are looking to set up their own networks in space. If we add up all of these projects, in under a decade, we could have at least 50,000 satellites orbiting the planet. Right now, there are about 20,000 cataloged artificial objects circling the Earth, only 2,500 of which are operational satellites. Starlink alone would triple that amount. I'll admit that this future sounds pretty cool, but at the same time, it worries me. Here on YouTube, people tend to go gaga over Elon Musk's projects. So on this occasion, let me level the playing field a bit. In this short trilogy, I'm going to explain why I think Starlink and other mega constellations could pose a threat to the planet for two reasons. Two concerns I think aren't really being discussed in the public sphere. We'll talk about that in future installments. But before we get down to business, we need to talk about the poor astronomers. Darkness is an astronomer's best friend, and in the modern world, it's becoming increasingly rare. The cheap electric lights we have today are making it hard to find truly dark places where you can clearly see all the details of the night sky. This problem is called light pollution, and it's one of the reasons why the world's most powerful telescopes are built in veritable sanctuaries of darkness. Remember that in order to take pictures of faraway galaxies from which we only receive a handful of photons, telescopes need to remain open for up to several minutes at a time, capturing light from that object. The danger is that if any strong light source appears, it'll mess up the photo. And this is where our friends the satellites come in. They travel at very high altitudes, so high that they may still be receiving light from the sun. If one happens to pass near your galaxy, game over. In the best of cases, the image will have a light streak running across it. In the worst, the intense luminance will confuse the photographic system and generate artifacts in the photo, basically rendering it useless. The streaks could be eliminated with a bit of processing, but that requires taking more photos, which means wasting the limited time the telescope has to operate. In a word, delays. Well, when mega constellations are a reality, this problem is going to be extremely frequent. 50,000 satellites in orbit means that no matter where you point, in a finger's width of sky, there will always be one or more satellites. Does this mean that the night sky on Earth is going to be one huge polka dot pattern? To be honest, no. First of all, positions. The Starlink satellites, and presumably those of other mega constellations, have a low Earth orbit, traveling in the region of space closest to our planet. This means that, for all their drawbacks, they're in the best possible place. As the Earth is so near, its shadow covers them fairly well, so they're mostly only visible close to the horizon. The time of year is also a factor. The way that the sunlight hits the Earth changes depending on whether it's summer or winter, and this affects the satellite's visibility. For example, in winter, the Cerro Tololo Observatory in Chile, one of the best places in the world to practice astronomy, expects to have a 6-hour window in the middle of the night when there are very few satellites in the firmament. Whereas in summer, the situation is reversed. With just 12,000 in orbit, they expect to see 20 satellites in the sky at any given time, mostly near the horizon. Bump up that figure, and things get ugly. The mere idea of an entire section of the celestial sphere being blocked because it's impossible to observe at a particular time of year is something that terrifies scientists. Now, let's talk about brightness. During the first launches, the Starlink satellites proved to be quite flashy in the deployment stage while they were reaching their operational orbit. They were bright enough to be seen from a city, and people observed flashes up to 60 times brighter, something visible to the naked eye even at sunset. Astrophysicists began to panic. In light of this situation, the folks at SpaceX with the best intentions began working on a way to reduce the glare from their satellites, giving rise to the new and improved Darksats. Tired of your mega constellation violating the Universal Declaration of Human Rights? Call the number on your screen and we'll give your overly reflective antennas a coat of black paint. Registered trademark. Watch your satellites cross the threshold of what the human eye can perceive. Yes! Darksats! Experimental product. Does not prevent glare or increase brightness during ascent maneuver. For more information, please see an astrophysicist. However, this is nowhere near good enough for astronomers. The people at the Vera Rubin have already said that if the brightness of the Darksats isn't reduced by more than half, the Starlink satellites will continue to cause artifacts in their images. In response, SpaceX is already launching its latest range of dark satellites, introducing Visorsat. Tired of your electronics overheating because you painted your satellite black? Ha! That wasn't such a great idea, was it? Well, now you can call the number on your screen to get a visor that gives you shade. No more light equals no more problems. Visorsat. Results not verified in the field. Also does not prevent glare. See an astrophysicist. The real problem here is that no matter how dark they make the satellites, telescopes will always end up detecting them. For instance, the Vera Rubin Observatory will be about 20 million times more sensitive than the human eye. If a satellite passes, reflecting sunlight, it'll leave an annoying streak that will have to be removed no matter how dark you make the gadget. Another issue is that these satellites aren't just annoying with visible light, they may also disrupt infrared and, more likely, radio frequencies. The thing is, the electromagnetic waves that these mega constellations plan to use fall within the same bands used by radio astronomers. This could generate a kind of background noise that messes with all measurements, endangering future interferometric discoveries like, for example, those being made at ALMA in Chile. The Starlink people are going to take steps to rectify this, but we don't know what will happen in practice or if other companies will show the same consideration.
But couldn't astronomers predict when the satellite will cross the area they want to observe and take measurements before or after it passes?
Good question. In theory, this is possible as long as the trajectories of all satellites are made public. There's been a lot of talk about how they're going to move dynamically, so the orbits would need to be updated in real time. SpaceX has already said they will publish this information. We'll have to wait to see if companies in other countries with different interests are willing to do the same. But even if they do, the problem is that this will render many observatories less efficient. Basically, the world's largest telescopes have long lines. Different scientific projects want to observe different areas of the sky that are only visible at certain times of year. So in order to fit them all in, when observatories focus on a certain area of the sky, they use this time to fill all the orders for that section. That way, they don't waste time moving the telescope back and forth. But if it has to stop every time a satellite passes, the window of opportunity for taking some measurements will close, and many of the projects will drop out of line or receive their data long after they should have. Plus, many things that happen in the firmament are unique events when there's no time to wait for a satellite to pass. Supernovas, occultations, gravitational lensing, mega constellations will hinder the progress of astrophysics.
But what if we sent all the observatories on Earth into space? If they're far beyond the satellites, there won't be any interference. Plus, we'll get rid of the turbulence that the atmosphere causes in images. Right?
Well, that's something good old Elon has already hinted at a few times, but it strikes me as a bit naive. The first problem, money. Sending a telescope you could build on Earth into space will easily add another zero onto the cost. Take this example. The money spent on the James Webb Telescope would be enough to build 7 ELTs with 6 times the diameter, completed in half the time, and equipped with adaptive optics and processing technology to eliminate any atmospheric interference. We talked about that in the first video on exoplanets. Moreover, the antennas on some radio telescopes measure 20 or 60 meters across. Where would we get the money to send something that big into space? Elon's also claimed that SpaceX's advances in rocket design could significantly reduce that cost. But aside from the fact that these are just promises, I personally think that stealing the sky from astronomers and then trying to sell it back to them is a Machiavellian plan. Another drawback is obsolescence. Once you send a satellite into space, you'll never touch it again. Even if there's a malfunction, going up there to replace instruments, mirrors, sensors, and such is prohibitively expensive. The Hubble is one of the few cases in which that effort was made. This means space telescopes are doomed to be more outdated than telescopes on Earth. Which brings me to this. Where do you think all the technology in space telescopes is tested first? Without telescopes on Earth, we'd have to constantly launch and relaunch telescopes until we found the optimal designs. In short, space telescopes really do need telescopes on the ground. If you make things harder for them, you're also harming the ones in space. I don't mean to imply that space observatories are a waste. Some measurements can only be taken outside the atmosphere, and it's worth the effort to make them. But others can be taken perfectly well here on the ground, saving a lot of trouble and money, which is already scarce enough in science. In conclusion, the rise of the megaconstellations won't destroy astronomy on Earth. I'm not such an alarmist, but it will definitely hinder many types of observations, like those made at twilight, those that require long exposures, or those that need to be done at a certain time of year. This is why astronomers hate Elon Musk. By now, you're probably saying,
What's the big deal? Sure, it's tough on astronomers, but that's the free market, bro. Why would this be a problem for the entire world?
Well, let's just say that turning a blind eye to what might happen in the sky has consequences. But we'll see that in another video. And remember, if you want more science, just hit the subscribe button. Thanks for watching!